the total energy we are supposed to calculate, which is equal to the sum of two energies, that is kinetic energy and potential energy. After writing these conditions, let us just get stuck ourselves into the electrostatic force, because that electrostatic force is the one which is very much necessary. When there is liberation of radiation, the energy decreases. When the energy decreases, it comes back and falls into the nucleus. Hello everyone, I'm Vrinda, Faculty of Physics from Vidhyaashram Pre-University College, Mysuru, welcoming you all to Session 3 of Chapter 12, Atoms. In today's class, let us look into the two derivations. That is, one of the derivation is like orbital speed of an electron which is revolving around the nucleus, and secondly, it will be the energy of the electrons which is revolving in the nth orbit. So let us look into these two derivations which are very important for 5 marks. Okay, either of the three, that is one derivation which was done in the previous session, as well as the rest two derivations which is being done today. So all these three derivations, either of the three will be asked for the exam, and it is for 5 marks. So going on to the orbital speed of an electron in a stationary orbit. So what is the speed of the electron? In order to, what is meant by a speed? Speed means a certain distance travelled within certain time interval. So now we are checking out orbital speed. Orbital means it is a circle. So the electron is revolving around the nucleus was the condition which was made by Rutherford as well as Niels Bohr. Niels Bohr told that the electron revolves around the nucleus in a stationary orbit. So here let us give the initial part, that is, consider an electron which is moving in a circular orbit. So this is a nucleus with charge Ze, and the electron is moving in a circular path which is given by these dotted lines, wherein your electron is present over here with the charge -e. Electron is having certain mass, call it as m, and its orbital velocity is v. So consider an electron which is moving in a circular orbit around the nucleus of charge Ze, that is a positive charge, because the nucleus consists of a positive charge which is embedded in it. Consider an electron moving in a circular orbit around the nucleus with charge -e, and mass of the electron is said to be m, with the velocity, that is the orbital velocity, v. So these are said to be the initial conditions of this orbital velocity of the electrons revolving in the stationary orbit. So after writing these conditions, let us just get stuck ourselves into the electrostatic force, because that electrostatic force is the one which is very much necessary for the electrons to revolve, that is to maintain its stationary orbit. So consider the electrostatic force of attraction. So we have electrostatic force of attraction is given by 1 by 4 pi epsilon naught, and the charge is mod of Ze and E, that is minus E. When the mod condition comes, minus goes out. So this is the charge of nucleus. E is the charge of the electrons which is revolving around the nucleus in a stationary orbit, divided by the square of the distance between them. That is, the distance from this to the orbit is said to be r. R is said to be the radius from the nucleus, that is the center of the circle, to the circumference. Circumference is nothing but the orbit of the electron. So, square of the distance between them. So, on rewriting this, you have 1 by 4 pi epsilon naught z e square divided by r square. So, we have this set of equation. Now, we know that according to centripetal force, because the force is exerted towards the center. So, the centripetal force is given by mv square divided by r, where m is said to be the mass of an electron, v is the orbital velocity, as well as r means it's a radius. So we have electrostatic force, that is E, and centripetal force Fc we have in our hands. Having these concepts, now mv square by r and 1 by 4 pi epsilon naught ze square by r, we have two set of equations. We have to equate these two set of equations because the electrostatic force is equal to the centripetal force. So, on rewriting this, we have mv square divided by r is equal to 1 by 4 pi epsilon naught ze square divided by r square. So, this r cancels with r square. So, what remains is mv square. I would like to take r towards my left hand side. So, I have mv square r is equal to ze square divided by 4 pi epsilon naught. I have this equation in my hand. So, suppose if you consider this as equation 1, now according to Bohr's second postulate, it is the electron revolve in a stationary orbit in such a way that its angular momentum is equal to integral multiples of h by 2 pi, where h is said to be the Planck's constant. So, angular momentum has another formula, mvr is equal to, angular momentum can be substituted, that is, since L is equal to mvr, we are substituting for L as mvr is equal to n into h divided by 2 pi. So, say this as equation 2. So, now divide equation 1 by 2, we have mv square r divided by this mvr is equal to, write this set of equation, ze square divided by 4 pi epsilon naught, and we are dividing this. So, mvr division nh by 2 pi. So, write nh over here, and divided by 2 pi comes like divided by 2 pi. Okay. So, now what happens? It is, rewrite this as mv square r divided by mvr, 2 pi goes to above, which becomes ze square into 2 pi divided by 4 pi epsilon naught into n and h. So, this is a set of equation where m gets cancelled with m, v cancels with 1v, and r cancels with r, and here pi cancels with pi, and we have 2 1 times 2 2 times. So, what are we left with? we are left with V is equal to, only V is remaining here, ZE square, Z into E into square, and divided by 2 epsilon naught N and H. So it is 2 epsilon naught N and H. So this is the set of equation which is remaining, that is the orbital velocity. So we can even rewrite this as V is equal to, take 1 by N towards the outside because N determines the orbits, number of orbits, and into Z E square divided by 2 epsilon naught into H. So this is the equation in order to calculate the orbital velocity of an electron in a stationary orbit. So for this derivation, there will be 5 marks which will be awarded if you write till here. So that is all about your orbital velocity of the electron, wherein you can give what is meant by V, that is the orbital velocity. Orbital velocity. What is Z? Ze is the charge on nucleus, and E is charge of electron, N is the number of orbit, epsilon naught is said to be constant, and H is nothing but Planck's constant. Like that you will have to label the part. So here ends this derivation. So coming to the next part, that is the total energy. We will have to check the total energy of an electron in a stationary orbit. So as Rutherford said that nucleus is at the center, electrons are at the outside of the nucleus which revolves around the nucleus. But what did he tell? The revolving of the electrons, there is liberation of radiation, due to which when there is liberation of radiation, the energy decreases. When the energy decreases, it comes back and fall into the nucleus. So if it has got a greater circumference during revolving, as there is decrease in energy, the circumference starts decreasing and finally the electrons come and fall into the nucleus. That was a Rutherford statement. But Rutherford's statement was given a slight modification by Niels Bohr. What did Niels Bohr tell? In his 3 postulates, the first postulate stated that it is non-radiating process. So there is no radiation which is emitted, due to which the electrons are said to be stable in a stationary orbit, and final conclusion was the atoms are stable in nature. So now we are finding out the total energy of the electron which is in the stationary orbit. So in order to find that, let us just consider the same introductory part which we had considered earlier. That is, there is a nucleus with the charge plus Ze, and the electrons are revolving around the nucleus, call it as minus E, with orbital velocity V, and the electrons are having certain mass, and the electrons are at a distance from the nucleus, call it as R. Okay, so write down the same introduction. Consider an electron of charge minus E revolving around the nucleus of charge Ze, which is at a distance of R from the nucleus, and the electron has mass m and is moving with certain velocity v. So when you just have the introductory part like this, we will get to know the scenario, what exactly is happening. So without writing any introductory part, if you just go on with the diagram and explanation, no, those who know the concept, they'll understand. But those who don't know the concept, like it'll be like they'll feel completely blank. What is this? What they have written, correct? In order to delete all those thoughts, it is our duty to just put a diagram and give a statement for it. That is an introductory statement. 1 or 2 lines is sufficient. Okay. That is, you will have to summarize in brief. So now, same to same as we had done in the earlier derivation, just take the electrostatic force of attraction. So we have by electrostatic force of attraction, we have electrostatic force is equal to 1 by 4 pi epsilon naught, and we have ZE square divided by R. Okay. So next is we have centripetal force. So how is the centripetal force given? That is FC, this is E and this is C. Centripetal force is equal to mv square divided by R. So we have two set of equations in our hands. Now we know that the total energy we are supposed to calculate, which is equal to the sum of two energies, that is kinetic energy and potential energy. As we have discussed in the earlier sessions, as you all have studied in the first PUC classes, kinetic energy and potential energy differences. That is, kinetic energy is the energy which is moving along the work done. Potential energy is the one which happens before the kinetic energy. So before the work is done, whichever energy is stored, that is called as potential energy, and stored energy is being used. We are making use of that storage. So that is nothing but the kinetic energy. So total energy is a sum of kinetic energy as well as potential energy. So we know that potential energy of the nucleus which is at a distance r is given as, consider it as U. So U is equal to 1 by 4 pi epsilon naught ZE into minus E is the charge of the nucleus and charge of electron divided by the distance of separation is said to be R, which can be rewritten as U is equal to minus 1 by 4 pi epsilon naught ZE square divided by R. So having this, we know that the kinetic energy is generally given as half mv square. So we have half mv square as the kinetic energy. Now let us equate two set of equations, that is electrostatic force as well as centripetal force, as we used to do in the previous derivations. That is, on equating Fc is equal to Fe, we have mv square divided by R is equal to Fe is 1 by 4 pi epsilon naught ZE square divided by R square. So your R gets cancelled with R. So what remains is mv square is equal to 1 by 4 pi epsilon naught ZE square divided by R. So consider it as equation 1. Substitute this equation 1. This is said to be equation 1. Substitute this set of equation, that is mv square, in kinetic energy equation. So now kinetic energy equation we are having as, that is this set of equation is like half mv square. So instead of this mv square, substitute 1 by 4 pi epsilon naught ZE square by R. So we have 1 by 4 pi epsilon naught z e square divided by r. So we can write this as 1 by 8 pi epsilon naught z e square divided by r is said to be the kinetic energy. So as we all know, what is total energy? It is T dot E. We write it as total energy T dot E. So now, considering total energy of electron in nth orbit. So we always consider the electron which is at the infinite distance, maybe the nth orbit. So total energy of an electron in nth orbit is equal to the sum of kinetic energy and potential energy. So what is your kinetic energy? It is 1 by 8 pi epsilon naught z e square divided by r plus you have potential energy given by minus 1 by 4 pi epsilon naught z e square by r. Minus 1 by 4 pi epsilon naught z e square divided by r. So this is the set of equation we have. So now on taking common, it's like 1 by 4 pi epsilon naught is common in both, okay, and z e square is common in two equation divided by r. So what happens within inside? So it is 1 divided by 2 plus into minus is minus and it is 1. 1 divided by 2 minus 1 is taken in bracket, 1 by 4 pi epsilon naught z e square by r is taken the other, that is a common. So now again on equating we have z e square divided by 4 pi epsilon naught into r and half minus 1, when you just take out the LCM you will get greater number sign and it is half. So again what do we have in our hands? It is minus z e square divided by 8 pi epsilon naught r will be the equation. So let us write total energy is equal to 1 by 4 pi epsilon naught z e square divided by r into minus 1 by 2, which was rewritten as En is 1 by 8 pi epsilon naught z e square divided by r and it is minus. So this is the total energy of an electron right now. And we know that the radius of the electron, that is radii of the electron which is moving in a stationary orbit. So which we had discussed, that is this derivation was discussed in the previous session. So we just write the radii of electron equation is given as Rn is equal to, since we are talking about the nth orbit, Rn is equal to, we have n square h square epsilon naught divided by pi m z e square bracket close. Okay, so this is the radii of electron which is moving in the n stationary orbit. So substituting for Rn, suppose if you consider this equation as equation 2, substituting for Rn in equation 2, we have En is equal to minus 1 by 8 pi epsilon naught z e square. Substitute for Rn, you have n square h square epsilon naught pi m z e square. So take this denominator towards the numerator. So you have minus 1 by 8 pi epsilon naught Ze square pi m Ze square divided by n square h square epsilon naught. So Ze square and Ze square fuses and it becomes Ze to the power of 4. So your pi cancels with pi, epsilon naught and epsilon naught, it becomes epsilon naught square. So you're left out with En is the total energy and it is minus 1 by 8 epsilon naught square Ze to the power of 4 into m divided by n square h square. So this is the equation. So the equation becomes Z and Z, it is Z square. So this is the set of equation which can be rewritten as taking the orbit outside n square into minus 1 by n square into Z square e to the power of 4 into m divided by 8 h square epsilon naught square. So this is the total energy of the electron in an nth stationary orbit. Suppose if you are considering hydrogen-like atom, it becomes H is a hydrogen-like atom you are considering. Then Z becomes 1. So your equation turns out to be minus 1 by n square e to the power of 4 m divided by 8 h square epsilon naught square. So this will be that set of equation and this is a final equation where E is the charge of the electron, m is said to be mass of electron, n is the orbit, which orbit the electron is revolving. H is a constant, that is Planck's constant, epsilon naught is also a constant. So now, what does this negative sign suggest? Negative sign suggests that, this negative sign is that the attraction towards the nucleus. It is the attraction towards the nucleus. So that is all about your total energy of an electron in an stationary orbit and which is very important for 5 marks. So I hope you're clear with today's concept of the orbital velocity of an electron in a stationary orbit as well as the energy of an electron in a stationary orbit. So these are the two sets of derivation along with the previously done derivation, that is the radii of the electron in a stationary orbit. And that's all for today. Let us all meet in the next session, that is Atoms chapter session 4. Until then, have a good day. Thank you.